All right, so let's do the same thing again. Let's try to get the graph of cotangent of x. And in fact, to some extent, I want you to do it. So here's what I want you to do if you're watching this video right now. Hit pause, fill in this page on your own, and then come back. Okay, good. You did it. So let's sketch the graph. So let's start by this. Let's get the period of cotangent of x plus pi. And again, you might just remember this, but let's also remember why it's true. So let's try to compute cotangent of x plus pi and see what we get. So cotangent is cosine over sine. So that's cosine of x plus pi divided by sine of x plus pi. Right, just because cotangent is cosine over sine. What does cosine do when I add pi to an angle? Well, remember, adding pi to an angle reflects the point on the unit circle that you get over the origin. So x values become negative and y values become negative. So cosine of x plus pi is negative cosine of x. Sine of x plus pi is negative sine of x. Just like last time, the negatives cancel, and you are left with just cotangent of x. So, because cotangent of x plus pi is the same as cotangent of x, cotangent has a period of pi. And maybe that makes a lot of sense because cotangent is really a very similar function to tangent. So in order to graph it, let's do a bunch of the same analysis. Let's try to determine where cosine is positive or negative. And cosine is cosine over sine. So if I know where cosine is positive or negative and where sine is positive or negative, then I'll be able to use that. Well, let's see. Those two functions, cosine and sine, look like this and this, respectively. Where this is sine and this is cosine. All right, well, let's start by just recording positivity, negativity. So cosine is positive from 0 to pi over 2, negative from pi over 2 to 0. Sine is positive from 0 to pi over 2. Oh, let's get color coding straight. Sine was positive. Well, it's positive on the whole interval. So cotangent will be, well, from 0 to pi over 2, it will be a positive divided by a positive, cosine over sine. So cotangent will be positive between pi over 2 and pi. Cotangent will be a negative divided by a positive. So it will be a negative divided by a positive, which will be negative. Between pi over 2 and pi, cotangent is negative. So in coding that down here, cotangent goes from positive to negative. Cotangent is 0 when the numerator is 0. When does that happen? And remember, I'm only interested in values between 0 and pi. So that means I need to know when cosine of x equals 0 if I want to figure out where cotangent is 0. Well, but looking at this graph, that is right here at pi over 2. Cosine is 0 when cotangent is 0 when x is equal to pi over 2. There is a vertical asymptote when the denominator is 0. So where is sine of x equal to 0? Well, though add 1 is the graph of sine, it looks like it is 0 at 0 and 0 at pi. So the graph of, there's a vertical asymptote of cotangent at x equal to 0 and at x equal to pi. And let's see. So close to x equals 0 from the right, either the graph will go to plus infinity or the graph will go to negative infinity. But it can't go to negative infinity because it's positive. So the graph will have a vertical asymptote at plus infinity when x is equal to 0. It needs to make it down to that x-intercept. It will then become negative and wind up down there. Cool. So copying that down, cotangent is doing something like this. And if I want to get the graph of tangent on the whole of the real line, now I can just repeat that pattern. Between 0 and 2 pi, I should see the same pattern again. Between 2 pi and 3 pi, between 3 pi and 4 pi, between negative pi and 0, between negative 2 pi and positive pi. So there's the graph of cotangent. And let's just do a quick sanity check. So we did just get the graph of tangent, which let's go ahead and remember what that is right here. You can see what the graph of tangent is by just looking at the previous page. The graph of tangent was 0 at 0. It had this vertical asymptote. Great. So, and this is it. I tried to keep the scale consistent from this graph to that graph, at least in terms of x values. So this should still be negative 2 pi, and this should still be x equal to 4 pi. Let's see, cotangent of x is equal to tangent of x plus some constant. Well, that's not actually true. But there is an identity that gives a relationship between tangent and cotangent. Let's just try to remember what it is. So let's just try some stuff. Let's just do it. So let's see, tangent of x plus pi over 2. Let's see what that is. So tangent of x plus pi over 2, that's the sine of x plus pi over 2, divided by the cosine of x plus pi over 2. No space there. Next line. So we have to remember what sine and cosine of x plus pi over 2 are, and either you can remember it, or, you know what, I think this is worth drawing a picture to help remember it. So there's rotation by some angle theta, and there's rotation by some angle theta, so some angle pi over 2 plus theta. So there's pi over 2 plus theta. So let's see, if this is some x, y coordinate, then that y coordinate is the length of this line. It's how far up you have to go. Well, it's the same thing as how far to the left you have to go. So this x coordinate is negative y. The x coordinate here is how far to the right you had to go. So there's the x coordinate. Well, it's the same thing as how far up you have to go. And that's the y coordinate over here. So what does this say? This says that cosine of theta plus pi over 2, because that should be the new x coordinate, is the same thing as negative y, it's negative the old y coordinate, is equal to negative sine of theta plus pi over 2. This says that sine of theta plus pi over 2 is the same as the old x coordinate. Well, that's the same thing as cosine of theta. So that gives me the two identities. Sine of x plus pi over 2 is the same as the cosine of x. The cosine of x plus pi over 2, on the other hand, is negative the sine of x, and we see that's the same thing as negative cotangent x. So what was written here would have been impossible to fill out correctly. That'll be corrected, hopefully, in the one that I'll put online by the time we make it here. So in fact, we see negative cotangent x is the same thing as the tangent of x plus pi over 2. So what does that mean? This means, in terms of graphs, that means that if we flip the graph of cotangent x over the x-axis, we get the same as if we shift the graph of tangent left by pi over 2. So I guess let's do that. Let's take this red graph and shift it left by pi over 2. So this point at 0, 0 will go there. So this is the graph of tangent of x plus pi over 2. Oh, but check it out. Between the blue graph here and this blue graph, it looks like they're almost the same, except this one is reflected over the x-axis. That's exactly what it should be. So this checks out. Let's also just answer some easy questions. Though I've kind of painted myself into a corner in terms of space. So by looking at this graph, because there's the graph of cotangent, and I think I'll just say this aloud, is that thing even or odd? Well, it's even, right? You flip that over the origin, you get the exact same graph back. There's a point on the graph. If you reflect it over the origin, you get that point on the graph. So it's odd. It looks like it's decreasing on its whole domain. You can see where it has x-intercepts. You can see that it has no y-intercept. It never crosses the y-axis because it has a vertical asymptote at the y-axis. Yeah. Cool. So I'll go ahead and stop there. Let's get this one posted.